Hello all, welcome to Code Hub. Let us solve today's LeetCode daily challenge. It is Fibonacci number. The Fibonacci number is commonly denoted f of n form a sequence called the Fibonacci sequence such that each number is the sum of two preceding ones starting from 0 and 1. Okay, that is the first initial Fibonacci sequence number is f of 0 which is 0, f of 1 which is 1, and f of n is nothing but for n greater than 1 we have to calculate the f of n minus 1 plus f of n minus 2. So given n, calculate f of n. So this is the problem. We can think of some recursive approach to this problem. First we can write the Fibonacci series. First, if n is equal to 0, then the sequence is 0. If n is equal to 1, the sequence is 0 and 1. And if n is equal to 2, then the sequence is 0, 1. Then the previous two numbers addition is 1 plus 0, which is 1. Then n is equal to 3, then the sequence is 0, 1, 1, 1 plus 1, which is 2. So this is the sequence, and if we have given the n is equal to 3, then we have to return 2. If we have given n is equal to 2, we have to return 1. If n is 1, we have to return 1. If n is 4, then we have to return 2 plus 1, which is 3. So this is the problem. So hope you understand the problem. So how we can think of this problem? We can go for this problem as iterative itself, but we will try to do first recursive approach. Then we will move forward for memoization, then we will move forward for tabulation, and then we will move forward for the space optimization, which will be the iterative solution. This is a basic problem for dynamic programming, so hope we can follow this order of giving the solutions, then you will be understanding more crystal clear. First, we can think of a recursive approach. What will be the function for f of n? What will be the recursive formula, recurrence relation? If I am given with f of n, the recurrence relation for this is f of n minus 1 plus f of n minus 2, right? So this will be my recurrence relation. Let us directly put this put this statement in our recursive function and see what we are getting returned. So we will write a recursive function, namely return solve, which is going to take the parameter as f of n, and I will declare a function which is giving the integer as the return value, return type, and it will take the parameters f n int n. So what will be the base case? The base case is nothing but if n is 0, we can return 0. If n is 1, we can return 1. So basically, if n is equal to 0, or if my n is equal to 1, we can just return n itself. So this will be my base case, right? Yes, this will be my base case. Next, what we are going to take is, we are going to take option 1. Option 1 is nothing but we will calculate f solve of n minus 1. And we are going to take option 2. Option 2 is nothing but solve of n minus 2. And finally, we are going to return the addition of both the options. That's it. So this is the recursive code. We can just run the code here. We got the output. We will use the example test cases as well. What will be the time complexity here? The time complexity for the recursive approach, I will write here. The first recursive, right? Recursive approach. Here the time complexity will be order of 2 power n. It will grow exponentially. For each n, we will be taking all the possibilities for n minus 1 and n minus 2. So it will go recursively. So it will go up to 2 power n. So it is growing exponential time complexity, and the space complexity will also go for till order of 2 power n. So it will be recursive stack space, recursive stack space. So we will try to submit. Anyway, it will get time limit exceeded. So we can go for the next memorization technique, and then we will try to submit the code. For how to do the memorization, we have the recursive code. It is very easy to give the memorization. We want to see what are the changing parameters. The changing parameters is only one parameter, which is n. So we can declare a 1D array in I will say it as, I will name it as dp, and I will name it for n plus 1. Since it is not going to be 0 index, so n plus 1, we have to get the answer for f of n itself. We have to get dp of 2 itself. We don't want to get dp of 1. It is not 0 based indexing, so I will declare for n plus 1. I will initialize it to minus 1 initially, and I will pass the dp to our function vector int with the reference we have to pass, since the value should be affected, and we will pass the dp to our function. And after this base case, we have to check for another case. If my dp of n is not equal to minus 1, then what I have to return? Then I have to return dp of n itself, and then I have to memorize it. We are caching the solution intermediate results. In this case only, dp of n is equal to option 1 plus option 2. Now we will try to run the code. Sorry, it is comma here. So we got the test cases passed, use example test cases passed. So we will try to we will write the time complexity, and then we will submit the code. Memorization, the time complexity will be order of n, and the space complexity will be order of n plus order of n. Where this is recursive stack space, auxiliary stack space. This will be my auxiliary stack space. Auxiliary, both are same. Recursive stack space and auxiliary stack space are both the same. Auxiliary stack space, that is taken while doing the recursion. So here when we get submit the code, this we will get our answer. We will try to submit the code. So this is a linear solution. It got accepted. So we have done the memorization technique, and now we will try to convert this memorization into tabulation approach. How we can try do the tabulation? We have to change this minus 1 to 0. Then we have to write the base cases. What is our base case? It is nothing but n. If n is 0, we have to say dp of n is itself. So dp of 0 is 0, and dp of 1 is 1. So this is our base case. This is our base case. So when we want to convert a memorization to tabulation, we have to go in reverse manner. That is, in my recursive solution, that is in memorization solution, the n goes from n to 0, right? It goes from n to 0. In this is in recursion. In tabulation, just opposite we have to do. N goes from 0 to n, right? This is our simple hint how to convert the recursion to tabulation. So we will write a for loop. Already we have the 0th value and first value, so we can go from 0 I equal to 2 till I is less than or equal to n. We have to get the n value, so I plus. So we have to just copy the recurrence relation inside this for loop. That's it. We have converted the recursive solution to tabulation. We will take this return and this dp of I, and we have option 1 and option 2, and we will convert this solve to dp of I minus 1, and this is dp of I minus 2. That's it. And dp of I will be option 1 plus option 2, and finally we have to return dp of n. So this is the tabulation code. We will take the recursive code as well. Now we will try to run the code. So here the in tabulation, what will be our time complexity? Tabulation the time complexity will be order of n, and our space complexity will be order of n. So we have eliminated this auxiliary stack space. So here the time complexity and our space complexity is very linear, and we can try to submit the code. We get error. We can handle that case here itself. If n is 0 or if my n is 1, we can just return n here itself. Now we will try to submit the code. Because this for loop will not get accepted. So it is faster than 100%. So it is a linear approach and it is most optimized. We can even more optimize this. We can even more optimize this space. We are taking order of n space. Hence, we can while observing that we are to calculate the current value. This is the current value, right? To calculate our current value, we have to get our previous. This is the previous value and this is our second previous value. So if we have if we maintain two variables, namely previous and second previous, we can eliminate this. If we can maintain value which is known as previous, second previous, and which is 0, and previous which is 1, and we can also have a variable called current. So we can eliminate this base case. Now my base case is nothing but this second previous itself. So we have the second previous, and to calculate our current, what we have to do is second previous plus previous gives me the current value. Next, for next iteration, we have to change our second previous and previous. So by this we can reduce the space complexity. This is nothing but previous, and dp of I minus 2 is nothing but the second previous, and my dp of I is nothing but my current. Now what you can observe here is 0, 1, and we have calculated 1. This consider this as previous. This is a second previous, and this current value I have calculated as previous plus second previous. So this previous plus second previous. Next, for next iteration, to calculate our current value, what will be my previous and second previous? Now my second previous is nothing but my previous, and my previous is nothing but my current, right? So we have to update this. Now my second previous is nothing but my previous, and now my previous becomes my current. So we can update like this, and instead of declaring another two variables, we can just add my current as previous plus second previous. So we can eliminate these two lines, and next for second previous becomes my previous, and my previous becomes my current, and again we will go for next iteration, that like we will update our second previous and previous. So this for here we have optimized our space to space optimization. Here our time complexity will be order of n, and our space complexity will be order of 1. We are just using two variables. We will run our code and see whether we are getting. Oh, finally we have to return dp of n naught. We have to return our current value. My current value stores the second previous plus previous, right? It got accepted. We will give some bigger values, 29 and 30 as well. We will run our code and see whether we get accepted or not. It is getting accepted, so our solution is right. We can submit our code. So it got accepted. So this is our linear solution, and we bind by space complexity with order of 1. So we have done a recursive approach, and then we have memoized it, then we have eliminated the auxiliary stack space, and we have done the tabulation, then we have eliminated our space also by using the space optimization by maintaining two variables. So hope you understand all the solutions, and we have completed the today's daily challenge. We will see in tomorrow's daily challenge. Until then, bye.